Okay, and then we have risk avoidance, and as the name implies, risk avoidance is simply opting not to do something, basically deciding that the risk is too high. So an example might be deciding not to patch a certain piece of infrastructure, maybe not to migrate to a new platform or launch a new site or a new service, simply because there's that fear that something may not go right. Okay, the risk is worth more than the reward, or the risk is higher than the reward, I should say. All right, so it's a business decision at that point, obviously, but again, you have to weigh the pros and cons. What's the benefit? What's the return? As I said, for whatever reason, that the risk of implementing that new piece of software or that new application or bringing this new site online is just too great. Okay, maybe it's a ding to customer confidence. Maybe it's the attack vector or the attack surface is too large and it just invites hackers, denial of service, or penetration attempts, or whatever the case might be. They just decide that it's not worth it. Okay, now there are some other risks associated with different environments, such as cloud computing and virtualization. Each present their own set of risks. With virtualization, as we know, it is basically taking a physical machine and either turning it into a virtual machine or creating a new virtual machine from scratch. So we can either P2V or physical to virtual, or we can create one from scratch. Either way, that virtual machine is subject to risk, subject to such things as outages, hackers. All right, so with outages, or with virtual machines rather, you run the risk of having a specific virtual machine go down. All right, now there are some disaster recovery and HA technologies in place with virtual environments that make that a little less likely. We can have failover, so it can go to a different cluster. We can move storage, or we can move VMs between clusters. So that is a benefit. But you also run the additional risk that if the actual cluster were to go down, then you're affecting more than just one VM. You could potentially affect 30, 40, 50 or more, just depending upon how many guests you have on that actual ESX or Hyper-V cluster or whatever your virtualization technology is. And then of course hackers are the same as well. You don't necessarily or you have the additional risk, I should say, of not necessarily just at the VM level, but if someone were able to hack into the hypervisor level, then you all run the risk of them having access or being able to do damage to more than just one VM. Okay, so on public clouds, again, similar sets of challenges. We have no direct access to troubleshooting of infrastructure. Again, because it's a public cloud, so we don't own the servers. We don't have physical access typically to that infrastructure. We're either renting it or we're setting up, even if it's a co-location facility, we still have somebody else managing that infrastructure. So we have a third party managing the infrastructure itself, and then we also have a third party managing the security, the patching, the updates, and so forth of that infrastructure typically. And then again, with virtualization, as I mentioned, if hackers can compromise the virtualization layer or the Hyper-V layer, okay, then they have access to the underlying systems. And then another thing to keep in mind is the physical separation of the systems is more difficult because, again, we have all of our VMs sitting on one server or one cluster. So in a traditional data center, you may have what's called four-corner security, or four-corner kind of DR, HA, whatever you want to call it, so that you may have physical servers separated by a couple rows or even decent amount of distance, depending upon how far and how large that data center is, but typically more than a couple of aisles apart. So that way they're separated in case a sprinkler head or something goes awry. You have a small fire and a sprinkler goes off. Typically that sprinkler may have, like, say, a 20 to 30 foot radius. So if your servers are physically farther than 30 feet, 40 feet apart, then you have at least that level of protection against one faulty sprinkler head or a small fire taking out all of your systems at once. Well, if all of your virtual machines sit on one cluster, obviously they're all basically inside the same piece of physical infrastructure. So that increases the risk a bit there. And then the separation of duty also becomes more difficult. Okay, the duties involved with patching, managing, all of that type of setup. So one ESX administrator has access basically to all of the virtual machines on that box. So again, just some challenges that are not necessarily insurmountable, but they require an additional layer of thought and additional layer of planning to make sure that they're spread out properly and that the risk is reduced as much as possible.